All right, here is your video lesson for lesson 3 on isotopes. So again, make sure you have your blue notes packet out. Some of these examples I believe are in your notes packet, so we'll talk through them. And if you need to go and review the video at any time, please do so. So these terms we already wrote down in your notes, but just to review them, the atomic number will identify the element on the periodic table. The atomic number represents the number of protons. So if you change the number of protons, you will change the element. If carbon has 6 protons and you add a proton to that atom, it is no longer carbon. Mass number you will calculate. It is not on the periodic table. Mass number describes one specific isotope, and mass number is found by taking the number of protons and adding them to the number of neutrons. Isotopes are different versions of the same element. So they're element with the same number of protons, but they have different mass numbers. So these examples, carbon-12 and carbon-14, would be isotopes of each other. They have different mass numbers, which is this number in the upper left, but they are just both carbon. So in your notes packet, you have these practice tables, and I apologize for my handwriting with the mouse. Hopefully you'll be able to read my numbers. But we'll fill this out together and talk through it. All right, so when you're given some information, you don't have to fill these out in order. I often don't. I kind of skip around based on what information is given. So what I do know is protons are positive, neutrons are neutral, and electrons are negative. So if I have 26 positive charges, and I know atoms are neutral overall, my positive charges have to equal my negative charges. So I know that I have, 26 electrons. I also know that mass number is equal to my protons plus neutrons. So if I take my 26 protons and add them to my 30 neutrons, I get a mass number of, 56. The element symbol, I would have to look on the periodic table. The element symbol is identified by the number of protons. So if I look on the periodic table, element number 26 is iron, which is Fe. And then in the symbol, in the upper left-hand corner, I'm going to include the mass number. So this will get really hard because the numbers are a little smaller. It's hard to write with your mouse. And then sometimes on the bottom left is another number shown, and the bottom number is the atomic number. So this one would be, I'm going to erase that, sorry. This one would be 26. So the bottom left number is the atomic number, top left number is the mass number. All right, I'm going to switch colors so you can see the second row a little better. So in the second row, I know I have a mass number of 41, and I know I have 19 protons. So if I have 19 protons, I can look on the periodic table. Element number 19 is potassium, which is K. The upper left-hand number is my mass number, so I can put 41 in the upper left. The bottom left number is my atomic number, so I can go ahead and put 19 right there in my symbol. Since I have 19 protons, protons are positive, that means I have to have 19 electrons. And then I know that my protons and neutrons have to add up to give me my mass number of 41. So if you take 41 minus 19, you get 22. So that's how you find your mass number. You know that protons and neutrons have to add up to equal that mass number. All right, I'm going to switch colors again. We'll switch over to the pink again. So the last example gives me 6 electrons. If I have 6 negative charges, I am also going to have 6 positive charges. Mass number is equal to my protons plus neutrons. So if I have 7 neutrons and 6 protons, I have a mass number of 13. And then for the symbol, the number of protons identifies the symbol, so the symbol on the periodic table is carbon. The atomic number of 6 goes on the bottom left. The top, left number is my mass number, which is 13. So that's where you get your atomic symbol. All right, make sure you have all of these written down. I'm going to erase quick and go to the next slide. So if you need to pause the video to make sure you have all of it, make sure you do so. All right, so for the next example, I am going to have you try it on your own. Oops, here are the answers to that top one. So this should be the second table in your notes. So take some time, pause this. Oh, actually, I'm gonna cross out one thing. You will not be doing the nuclear charge, so do not worry about that column. You can cross that column off. So take a second, fill in the rest of these blanks best you can. Go back to the first example to hear the explanations, but pause this video, take some time, write in your answers, and then once you unpause to check the key, if any of your answers were wrong, then you can erase them and fix them, but always go back and make sure you understand why your answer is wrong. And if you're not understanding why, be sure to ask. So take a second, pause the video. All right, here are your answers. So again, you don't have to worry about this nuclear charge column, but these should be the answers that you get. So take a second, check your answers. If you need to pause, please do so. The bottom question asks which two elements are isotopes. So remember, isotopes are elements that have the same number of protons, but different mass numbers, meaning they have different number of neutrons. So bromine 75 and bromine 82, they're both bromine, but they have different mass numbers. So those two elements are going to be your isotopes. So you'll have more practice like this in your digital notebook, and actually there's plenty of practice, but by the end of the week you will have a short quiz that covers this information as well. So take some time, process your thinking, ask questions, make sure that you fully understand before you try that summative assessment on Friday.